Okay, today you can go ahead and see that I've calculated the values for a series circuit. In my series circuit I have a source voltage of 5 volts. I also have different resistors here. I have resistor 1 which is 120 ohms, resistor 2 at 300 ohms, resistor 3 at 1.2 kilo ohms, and resistor 4 at 2 kilo ohms. When I go ahead and do a series circuit, I like to use a technique I call guess. My guess technique, first thing I do is list out my givens. I've already listed all my givens here. There are those values that I already mentioned to you. The next thing I do is list out my unknowns. I do not know my resistance total. I do not know my current total. I do not know my voltage at each one of those resistors. Remember, in a series circuit, voltage changes throughout the circuit. In a parallel circuit, our current changes and the voltage stays constant. You can see I've already done all the work here. I've got the next step in guess is an E, which is for equations. I've written up there V equals IR. I've also written up there my equation for finding resistance in a series circuit. Resistance total equals resistor 1 plus resistor 2 plus resistor 3 and so on, no matter how many resistors we have. The next step is substitute and solve. I like to put those together because I don't like to do the extra steps of substituting and going back and solving later. So the first thing I went ahead and did was I solved for my resistance total. Notice that I went ahead and put all of my units back in base units. So instead of 1.2 kilo ohms like we have over here for resistor 3, I actually put it in as 1200 ohms, and same thing for the 2 kilo ohms. Put it as 2000 ohms. Goes ahead and calculates out for a resistance total of 3620 ohms, 3620. Now I convert that back to SI prefixes, so I went ahead and moved my decimal place 3 places to the left. That's in the positive, so my unit with a power of 3 is kilo ohms. So you can notice over here that I wrote 3.62 kilo ohms. Next, I went ahead and found my current total because I have my voltage total of 5 volts and my resistance total of 3,620 ohms. I do some math there. I take 5 volts divided by 3,620 and it gives me a current total of 0.00138 amps. Now once again, that is in base units. I can convert that. Now on this one I went negative. I went into the negative or beyond the decimal place. So I looked at my chart and I know I have to the power of negative 3 to get back here, which gives me 1.38 milliamps. So once I find my answer over in my work, I go ahead and bring it back to my list of unknowns. Then I continue on to do all of my voltages at my different resistors. On each of those, we're going to use that V equals IR equation. You can see right there that I have those written out. I'll zoom in just a little bit on those so you can hopefully see better. And right there I have my voltage at resistor 1. Voltage at resistor 1 is going to be equal to our current times our resistor at that voltage. So once again we have a resistance of 120 ohms and our current is the same for each one of these because in a series circuit current stays constant. We go ahead and multiply these two numbers together, we end up with 0.1656 volts. Once again, if you look over at my unknowns list, I'm going to go ahead and pan back over there. You can see that I went ahead and changed that to 165.6 millivolts. That way I could go ahead and get it written down there. Once again, we come back over here. You can see voltage at resistor 2. Once again, change out the resistance value. Current stays the same. And we end up with 0.414 volts. We come back over to the unknown list and you can see that I converted that to, let me tip down a little bit so that we can see it a little better there. I converted that to 414 millivolts. I can zoom in on that list when we're done here. Back over to my equations. You can see the VR3. Once again, note that I did not leave it in milliamps or kilo ohms. I went ahead and actually converted them back to our base units. In this situation, it would have given you the correct answer if you did, just because they cancel each other out, but we do not want to do that. So I converted them back, came up with 1.656 volts. Worked out perfectly. Put that back over in my list right there. And the last one is resistor 4, 0.00138 amps times 2000 ohms gives us 2.76 volts. once again in my list there for my unknowns. I'm going to zoom in on that just a little bit so you guys can see what all my unknowns came out to solve for. Now, once I went ahead and did this, we learned about Kirchhoff's voltage law. Remember that Kirchhoff's voltage law works for series circuits. If we were dealing with a parallel circuit, we would use Kirchhoff's current law. The idea of Kirchhoff's law is that in series, all the voltages should add up to our source voltage. In parallel, all of our currents should add up to our source current. So remember we had 5 volts in this. If I look up here, there's 5 volts. So if I come over here to this side of the board, you will see that I did a little bit of math real quick there that says I add up all those voltages I came up with. 0.1656 volts plus 0.414 volts. Notice I changed those back to base units. Plus 1.656 volts plus 2.76 volts. All of those add up to 4.9956 volts, which is pretty close to our 5 volts. The reason we're off by a little bit is the fact that we went ahead and rounded. So that is what we would go ahead and do with a series circuit. I'm going to go ahead and pan back here and zoom out so you can go ahead and see my work again. Hopefully this is high enough quality that you can go ahead and see it on YouTube. So there's my givens, my unknowns, my equations, my substitute, my solve, and over there my Kirchhoff's law double checking my work. Hopefully this is helpful for you. Thank you.